No technology in history has generated more passion. No technology in history has evoked such suspicion and fear.
It is the most evil, most health-degrading type of energy that there is. It's just the stupidest way I ever heard of to just boil water to generate electricity.
America's nuclear power industry is failing, crippled by public opposition, mounting costs, and a politically intractable nuclear waste problem. Its critics have already declared victory.
Nuclear power is dead. There will not be another nuclear power plant built here ever. I mean, it's nothing that we really have to argue about. Nuclear power is unsafe, it's uneconomical, and it's opposed by an overwhelming majority of Americans. Citizens distrust the technology. Wall Street distrusts the economic gamble. Nuclear power is dead. It's over. It's that simple.
If the critics are right, the final resting place for the waste from 4 decades of commercial nuclear power may well be here, buried under a remote stretch of the Nevada desert called Yucca Mountain. I'm Richard Rhodes. I spent 15 years studying the history of nuclear energy. I wrote about it in my book, The Making of the Atomic Bomb. I find it extraordinary that half a century after the discovery of this new source of energy, I'm standing on what may become its burial ground. How did it happen that the nation that first harnessed this awesome new source of power is about to abandon it? What is it about this technology that stirs our passions? Atomic energy burst upon the world 52 years ago in the New Mexican desert. In July 1945, scientists in the top-secret Manhattan Project prepared to test an atomic bomb. They knew they were unleashing a force of mythic proportions. Physicist Robert Oppenheimer paid homage in the words of a Hindu god, "Now I am become death, the destroyer of worlds." A few weeks later, the world learned about atomic energy when the US bombed Hiroshima and Nagasaki. I remember the awe I felt as a boy when I heard about the destruction these new bombs caused. They shocked the world and ended a long and terrible war. Once discovered, this astonishing new technology could not be forgotten. The atomic age had begun. But instead of destruction, scientists dreamed of harnessing the power of the nucleus, offering humankind a source of limitless energy. By 1951, American scientists had taken the same nuclear power that had destroyed Hiroshima and Nagasaki and used it to turn the lights on.
It was a very exciting field. We thought it would be the leading method of making electricity throughout the world. You have a very small amount of space, 12 feet tall, 12 feet in diameter, and you produce enough electricity to run a large city in that small space. So the energy source is extremely concentrated, which is one of its great benefits.
The source of nuclear fission is uranium, a naturally occurring metal. Before the war, scientists discovered that a small fraction of the uranium atoms found in nature, less than 1%, have a special property. When they're hit by neutrons, they split, releasing more neutrons that in turn can split other uranium atoms. Each split or fission releases large amounts of energy. By fabricating thumb-sized uranium pellets, loading the pellets into fuel rods, and assembling the rods into a core, scientists were able to produce a self-sustaining chain reaction that yielded enormous quantities of heat. The core's energy heats water, producing steam, that drives turbines, which generate electricity. Proponents argued it was a dream form of clean energy that would be too cheap to meter.
This new type of power reactor supplied citywide the kind of energy which will someday power man's factories.
But this rosy view of a nuclear future always had to compete with darker images. From terrible explosions and the end of civilization, to nightmarish mutations induced by radiation run amok. By the 1970s, nuclear power had become a political target. Its leading critic was Ralph Nader.
The Atomic Energy Commission is licensing unsafe reactors operating near major metropolitan areas, and that they clearly have been aware of this lack of safety.
The press wasn't critical. The Congress bought into the Atomic Energy Commission party line. There was a huge taxpayer-funded propaganda about how good nuclear power was, going right into the high schools and elementary schools in our country with traveling road shows. The scientific community was part of the industry itself, and there was no outside critique, there was no government critique, and there was secrecy above it all.
Then in 1979 came 3 Mile Island.
Good evening. The world has never known a day quite like today. It faced the considerable uncertainties and dangers of the worst nuclear power plant accident of the atomic age.
It seemed to confirm our worst fears, that in trying to exploit nuclear fission, we had opened a Pandora's box. A series of technical and human errors led to a partial meltdown of one 3 Mile Island reactor. The accident riveted America. Nothing would ever be the same. While no one was injured or killed in the accident, the experience helped forge a generation of hardened anti-nuclear activists like Eric Epstein and Mary Osborne. They are convinced beyond doubt that nuclear energy is dangerous, that it kills people in an invisible and insidious way.
But I think what's interesting, if you look...
They want to wipe it off the face of the earth.
I don't trust these people. These people got away with murder. They killed people. And, you know, radiation is difficult to pin down. It's not like I put a gun to your head and shoot you. You know, with radiation, it's going to be difficult to determine, you know, if a certain disease was caused by it.
Since 3 Mile Island, researchers have studied public attitudes extensively. They've found that people's doubts about nuclear power have increased with time.
But let's go back now to your word association, associated with nuclear power. And I want to just go around the table, and we'll start with Leo and go that way. What's your first image?
Disaster.
Disaster. David, what's your first image?
The first image I had was trouble.
Trouble.
Disgusting.
Disgusting.
My first word was dangerous.
The first thing I thought of was radiation.
Radiation. I'm going to read...
Strong nuclear reactions. Like this focus group, many people fear radiation. But scientists like John Mulder, who work with radiation every day, feel differently. If we knew what they knew, they argue, we might feel less afraid. Biologists measure radiation in small units called millirems. Whether or not it's dangerous depends on the dose.
A sufficiently large dose of ionizing radiation, and here we're talking of millions of millirem, will actually kill you on the spot, within seconds. Getting down to somewhat more reasonable doses, hundreds of thousands of millirems, these can also kill people. It takes a while, typically 7 to 21 days. There were people in the Chernobyl accident, some of the firefighters, who got doses in this range, 200,000 to maybe 600,000 or higher millirem, and they died as a result of this. This is called acute radiation poisoning. Once you get below roughly 200,000 millirem, this doesn't happen. People do not get acutely sick as a result of radiation exposure. What they are, however, is at an increased risk of sometime in the future developing cancer.
Much of what's known about the effects of radiation was learned in the aftermath of Hiroshima and Nagasaki. In one of the largest studies ever conducted, 50,000 Japanese bomb survivors were followed up for 50 years to see if their cancer rates increased and whether they passed on genetic mutations to their children. Much to the scientists' surprise, there was no increase in inherited mutations. Despite the science fiction films, this fear proved unfounded. Cancer rates did increase, though, especially among those exposed to more than 10,000 millirems.
Of those 50,000 people, about 5,000 of them have developed cancer. Based on what we know of the rest of the Japanese population, you would have expected about 4,500 of them. So we have 5,000 cancers over 50 years where we would expect 4,500. So we assume that those extra 500 cancers were induced by the radiation.
2, 3, go!
Not surprisingly, some of the citizens living near 3 Mile Island see parallels with Hiroshima.
Good job!
At the time of the accident, we left the area, and when we got to my mother's home, my son went into the bathroom and threw up. He had thrown up a vile green slime. There was no other way to explain it but that. No food, just heavy, thick mucus. And it was the color of a commercial cleanser. Approximately 6 months later, some doctors came in who dealt with the victims from Hiroshima and Nagasaki in Japan. I told him the story about my son, and he said, well, that's a classic case of radiation sickness poisoning.
But Mulder is skeptical because the dose at 3 Mile Island was so much lower than Hiroshima.
In the case of 3 Mile Island, it makes no sense whatsoever. We have a very good idea what the doses to the population were around 3 Mile Island. Most of the population got something in the neighborhood of 2 to 10 millirem. To get radiation sickness, you need 200,000 millirem.
Okay, let's go find.
But could the authorities have lied about the amount of radiation that was released?
There is no way in a technological society you could conceal radiation exposures that high. A dose high enough to cause radiation sickness would, for example, have fogged common photographic film for hundreds of miles. Any photographer would have noticed it. Any hospital that did x-rays would have noticed it. Any dental studio would have noticed it.
The Environmental Protection Agency, the Nuclear Regulatory Commission, the state boards of health all concluded that extremely small amounts of radiation were released. Small compared to what? Certainly compared to Hiroshima, but also compared to the radiation we get from nature. The average American, myself included, gets about 350 millirems of radiation each year, most of it unavoidable.